Hi everyone. This is the third part of our video series on unit circle. I broke it up into three because it was way too long for one. Basically, first part I talked about deriving the unit circle so you guys could see where the information comes from. Basically why each point on the unit circle gives you cosine and sine for that angle. In part two we did drawing the unit circle, just how to know where all the angles are in both degrees and radians, and then for each point how to figure out what the values of that point are. And now finally for part three, we're going to use the unit circle to answer questions. So here are the steps to using the unit circle. Number one, you got to know the angles. If I ask a question about a certain angle in either degrees or radians, if you don't know exactly where on the unit circle that angle is, you're not going to be able to answer the question. Number two, once you know where the angle is, you have to know what point it corresponds to on the unit circle. And again, if you're having trouble with that, watch the part two video again. We talk a lot about that. Also, before I go on to number three, from bullet point number two here, once you know the point, the x part gives you cosine for that angle, and the y part gives you sine. So you got two automatically without doing any work, just by knowing the angle and knowing the points. Now, if you need tangent, we know that tangent is sine over cosine for any angle, for theta. So just use the two values. Take the y value, which is sine, put it over the x value, which is cosine, simplify it, and you have tangent. And if you need any of the other three trig functions, just use reciprocals. If you need secant, take cosine and flip it. If you need cosecant, take sine and flip it. And if you need cotangent, take tangent and flip it. All right, so here's our first example for today. It says, we're not even going to do the trig part yet. We're just going to practice finding angles and points. It says, what point on the unit circle corresponds to theta equals 5 pi over 3? So it's kind of a two-part question. The first part is just, where is 5 pi over 3? And you got to know this. If you don't know where 5 pi over 3 is, you can't do anything else with the unit circle. So here's my not very good unit circle. It's hard to draw on the computer. But basically what you want to do is know that 5 pi over 3 is this one right here. If you're thinking about the unit circle, which starts here, this is 0. If I'm going around the unit circle, 5 pi over 3 is the first one past the very bottom. You know, as past the third, once you enter the third or the fourth quadrant, it's the first one there. So we want to know those angles. We want to know exactly where 5 pi over 3 and every other angle is. Now the question becomes, what is that point right there? Now, if you don't have it all memorized, or you don't have a picture of the unit circle in front of you, remember in part two I said just think in terms of triangles. That's a point in the coordinate plane. To plot it, I went over this much and down this much. That's a 30, 60, 90 triangle. In a 30, 60, 90, the shorter side is always 1/2. The longer side is always radical 3 over 2. So if I'm thinking of the answer to the question, x comma y, for my x value, I went in the positive direction 1/2. So that's positive 1/2. For the y value, I went down, which is in the negative direction, negative radical 3 over 2. And that's the answer to the question. All I ask you for now is to just tell me what point that is. That is the point 1/2 comma negative radical 3 over 2. Okay, so the next step is, let's go one step further. Let's find the point, which is the first part of this question anyways, but then let's answer questions about trig functions. And in this question, I'm asking about all of them. Tell me all 6 trig functions for theta equals 3 pi over 2. So just like the last question, the first step, draw my unit circle again. The first step is to find the angle. Now 3 pi over 2 is the very bottom of the unit circle. 3 pi over 2 is this angle right here. So the point that I'm looking for is right there on the bottom of the unit circle. Now remember, that's what we call a quadrant angle, and we don't do triangles for this. We just do it in terms of zeros and ones. So what that is, remember the unit circle has a radius of 1, so that point at the bottom of the unit circle is down 1 and over nothing. So the x value of that point is 0. That point does not go right or left from the middle at all. The y value is -1. So that's the point 0, -1. And in the last example, that's all I asked you. In this example, I asked you guys to tell me all 6 trig functions. So let me actually make a quick answer column here since we're doing them all anyways. I'm going to say sine theta equals, cosine theta equals, and tangent theta equals. And then we'll do each reciprocal. Cosecant theta equals, secant theta equals, and cotangent theta equals. Now, for the answers, 2 of them we get automatically. The x value, that's cosine. So cosine theta equals 0. The y value is sine. So sine theta is -1. Now for tangent, we're going to do cosine over sine. I'm sorry, sine over sine over cosine. Sorry, I was getting switched up with tangent and cotangent. Tangent is sine over cosine. In fact, I'll even write it out. Tangent theta equals sine theta over cosine theta. Now, using your answers straight from the table, that would be -1 over 0. Now, dividing by 0 gives you undefined. So tangent theta for this angle is actually undefined. Now, for the last 3, we're going to take reciprocals. So for cosecant, I'm going to do the reciprocal of sine. Now, sine is -1, which as a fraction would be -1 over 1. If you flip a 1 over 1, you get a 1 over 1, and it stays negative. So cosecant theta is actually also -1. Now, the last 2 are interesting because cosine is 0. And you think, okay, well, what's the reciprocal of 0? Let's kind of do the same thing here. Let's say if cosine is 0, I could think of that as 0 over 1. Well, if I flip a 0 over 1, I get 1 over 0, which is undefined. And here's the last one that's a little bit tricky. A lot of people will look at this and go, tangent is undefined, so it doesn't have a reciprocal. So maybe cotangent is also undefined. And that's actually not right, because remember, the reason tangent was undefined is because it was -1 over 0. If I flip -1 over 0, I get 0 over -1. That's not undefined, that equals 0. So remember, if you get a 0 on bottom, it's undefined. If you get a 0 on top, that's an answer, it's 0. So cotangent theta in this question actually ends up equaling 0. And a good way to think of it, just think of 0 and undefined as reciprocals. If one trig function is 0, its reciprocal will always be undefined. And if one trig function is undefined, its reciprocal will always be 0. So that was kind of a tricky one because there was a couple undefined answers in there because of that 0. But those 6 things are our answer right there. This, box it up here, all of this is our answer to the question. Okay. So for the next question, we're going to do the same thing, but this time with 2 things. Number 1, it's going to be triangles because we have a radian angle over 6 there. And number 2, it's not on the unit circle. Like the number 29 pi over 6 is obviously way too big for the unit circle, plus it's negative. So what I'm doing is I'm combining this with something from section 1 on coterminal angles, where we want to turn this into an angle we're more familiar with. So let's do that. I'm going to take my angle, -29 pi over 6, and I'm going to say, let's find some coterminal angles. Let's add 2 pi. And what I'm going to do is I'm going to add 2 pi as many times as I need to until I see an angle that I like, until I see something familiar from the unit circle. So in order to do this, I'm going to put the 2 pi over 1, find a common denominator by multiplying by 6, and basically what I'm going to do is I'm just going to keep adding 12 pi over 6 until I see something I like. So if I do it once, I would have -17 pi over 6. I still don't like it. Let's do it again. I would have negative 5 pi over 6. That's okay, but I'd rather it not be negative. I could work with that, but I don't want to. So I'm going to do it one more time. Negative 5 plus 12 gives me 7 pi over 6. So now what I'm thinking to myself is, instead of negative 29 pi over 6, which is a weird angle, I had no idea where that was. By using coterminal angles, I know this ends in the same place as 7 pi over 6, and now I can just use 7 pi over 6 for the rest of this question. So all of a sudden, let's do my unit circle over here. The point that I'm looking for on the unit circle is 7 pi over 6. And remember, you guys got to know these angles. 7 pi over 6 is the first one past halfway. If I'm starting here, it's right there. Going around the unit circle, go past pi, the very next one. That's 7 pi over 6. So then I think to myself, okay, well, what's the point on the unit circle? Well, for the point on the unit circle, it's over this far, down that far. They're both going to be negative because it's left for x and then down for y. Those are both negatives. The longer leg is going to be the radical 3 over 2. The shorter one is going to be the 1/2. So that point that I'm going to use for this question, negative radical 3 over 2, that's the x part, longer leg to the left, negative 1/2 for the y part, shorter leg and down. And now let me do the same thing I did for the last example. Let me make an answer column. Sine theta, cosine theta, tangent theta. I always start with the main three. And then I do each reciprocal. Cosecant theta, secant theta, cotangent theta. And we get 2 for free. So right here, the first x value is always cosine. So this is negative radical 3 over 2. And the y value is always sine. So this is negative 1/2. Okay, now tangent is going to be sine over cosine. So let's use those two values. Where can I squeeze this in? Maybe above the unit circle there. Sine over cosine would give me negative 1/2 over negative radical 3 over 2. Now two things happen. Negative over negative is positive, so tangent is definitely going to be positive here. And also, one of the things that's kind of nice, the way it works out, sine and cosine always have the same denominator when they're fractions. And when you when you divide them, those twos just cancel out. So negative over negative becomes positive. What I get for tangent is positive 1 over radical 3. And you guys might remember from years past about rationalizing denominators, like I'm supposed to multiply top and bottom by radical 3 and give my answer as radical 3 over 3. I don't need you to do that. That's kind of extra work. It's nice if you do it, but it's not required on things like the AP Calculus test. So I'm not going to require it for you either. You're welcome to leave a square root and a denominator for me, and I'm fine with that. Okay, now for each of the bottom 3 answers, just flip your top 3. So for example, if sine is negative 1 over 2, cosecant is negative 2 over 1, or basically just negative 2. Same with cosine. If cosine is negative radical 3 over 2, then secant is negative 2 over radical 3. And again, you can leave the radical 3 in the denominator. I'm fine with that. And then finally for tangent, tangent is 1 over radical 3. Cotangent is radical 3 over 1, or just radical 3. You don't really need the over 1. And there's your answers. 6 trig functions. Everything came from this point right here, from sine and cosine. So the whole key is know where the angle is, know what the point is, know how to use it, and you can get any or all 6 of the trig functions. Here's one last question on the unit circle, and it's an interesting one because I said find all 6 trig functions again, same setup. For theta, if the terminal side of theta crosses the unit circle at the point 5 over 13, comma, negative 12 over 13. Now, if you remember from part 1 on the video, I said, even though we focus on 30s and 45s and 60-degree angles, the unit circle works for anything, and that's what's happening here. If this is the unit circle, and we're looking at the point, it's not a very good circle again, but we'll deal. If I'm looking at the point positive 5 over 13, comma, negative 12 over 13, it would probably be about here. Positive 5 over 13 means to the right a little bit less than halfway. Negative 12 over 13 means down most of the way, and that's where that point is. So we're looking at this angle right here. Now you might think to yourself, oh, that's 300 degrees. It looks like it's close to 300 degrees, but it's not 300 degrees. If that was 300 degrees, those two numbers would be different. Those would be the point 1/2, comma, negative radical 3 over 2. So it's close to 300, but it's not. This is one of those where maybe it's 295 degrees or 291 degrees. We don't know what it is, and it doesn't matter what it is. Either way, this is cosine, and this is sine for theta, for whatever angle that is. So let's just answer the question. I mean, we didn't even I drew the picture just as a visual for you guys. You didn't need that picture to answer this question. You could have jumped straight to the answers. So let me make an answer column one last time. We have sine theta, cosine theta, and tangent theta. And then maybe I'll do the reciprocals next to them. Cosecant, secant, and cotangent. So I already wrote cosine and sine in yellow. Cosine theta is 5 over 13. Sine theta is negative 12 over 13. Now for tangent, you do sine over cosine. Negative 12 over 13 over positive 5 over 13. The 13s cancel. They always do on this step. I told you on the last slide. So you get negative 12 over 5. And then we finish it up with the easy part. Flip each answer. This one would be negative 13 over 12. This one would be positive 13 over 5. And this one would be negative 5 over 12. Just flip each answer. So that was just showing you that, yeah, we study certain angles on the unit circle because they're convenient, the multiples of 30 and 45 degrees. But any point on the unit circle works. If I pick a random point like this and tell you it's a point on the unit circle for some angle theta, I'm giving you cosine and sine for that angle. I'm going to wrap up today with a vocab term. There's something called a reference angle, and you might see it, mixed into homework or a note somewhere, and I just want you to know where it is, or know what it is. A reference angle is the angle in the unit circle that you actually use to make a triangle, like the SOHCAHTOA part. And let me just give you a quick picture so you know what I'm talking about. Say this is my unit circle, and let's say we're doing the angle 150 degrees, which is right here. This angle right here is 150 degrees. But when you're finding that point, what you're actually using is this triangle right here. Those are the values, the radical 3 over 2s and the 1/2 that you use to find the point. And the way we do it is using that little right triangle there. So this angle in the triangle is what we call the reference angle. In this case, the name for it, usually if the angle you're talking about is theta, we call it theta prime. If you put an apostrophe on it, that's usually the reference angle. And for this one, it would be 30. And you can tell just because a straight line is 180, the theta, the main angle is 150, 180 minus 50 is 30. So the reference angle there is 30. It doesn't affect what we're doing. We're still answering questions the same way. I just want you to be aware of that phrase, reference angle, in case you see it somewhere. I don't want you to read something about a reference angle and feel confused and not know what it is. Other than that, we're basically finished. You guys definitely know how to use the unit circle now. It's number 1, find the angle. Number 2, find the point. Number 3, use the point. And that might be finding sine, cosine, tangent, secant, cosecant, or cotangent, or finding all 6 of them like we did. If you can find all 6, you can definitely find any one. And that's what the unit circle is for, is being able to quickly and easily evaluate any or all of the 6 trig functions for any or all of the angles on the unit circle.